Now today we start a new topic of the section 1, solution. So all of you well known, we require the number of solutions in the chemistry. So the life on our earth is possible because it is surrounded by the air which contains a different gas like oxygen, and hence that oxygen which is known as the pranavayu. In addition, 2/3 of the earth is covered with water, the most essential vital components for life, water which is known as the G1. Water in the sea is not in the pure form. It contains NaCl, MgCl2, CaCl2 and gases like oxygen, carbon dioxide in dissolved state, and that sea water which is known as the solution. But the study of chemistry is incomplete without the study of solution, and hence we introduce the part of the solution. Dear friends, all of you are familiar with mixtures. The mixture is the combination of two or more substances like air, like rock. Air is the mixture of gas, rock is the mixture of two or more mineral, and so on. In 11th standard, we already learned homogeneous and heterogeneous. So tell me, what is the homogeneous? Homo means same. Geneous means to form. Homogeneous in which the mixing of component in uniform, that is sugar solution. So whenever we mix a sugar in water, we stir continuously. After a few minutes, we can understand the solution is showing the transparent, which is known as the homogeneous. Now heterogeneous. Hetero means different. Geneous means to form, which have non-uniform mixing of component. For example, oil in water, in which two phases are showing. One phase is there, liquid, but upper layer is showing the oil, lower layer is showing the water, and hence we say that it is in the non-uniform, which is known as heterogeneous. Homogeneous mixtures are classified according to their size of their constituent particles as a colloids or as a true solutions. But colloidal suspensions are terms we already learned, and the true solution, there is a difference in between of them depend on the particle size. In the dispersion, it carry positive or negative charge, while in the true solution, it is formed when the soluble substances are dissolved in the solvent. Particle size of the true solutions are very small, according to 10⁻⁸ centimeter. So let's we start the types of solution. We generally think that solution is either solid, dissolved in liquid, or mixture of two different liquids. The solute and solvent, there is one more difference in between of the solute and solvent. Solute which is always in the small, while the solvent in the large quantity. So when the solute and solvent, when they get added, we get the solution. That is, the solution is the combination of solute and solvent. The solution may involve any combination of these three states, that is solid, liquid or gas. This gives rise to 9 different types of solution depending on the state of solute and solvent, which showing in the tabular form. Now this one, the state of solute and state of solvent. First of all, solid and state of solvent is the liquid. The good example is the sea water. Here we can take also the same example of the sugar water. Now the second one is the solid. Example is metal alloy. In the third one, solid gas. Example is iodine in air. Fourth one, state of solute liquid, state of solvent liquid. Example is gasoline. Fifth one, liquid solid. Example is amalgam of mercury. In the sixth one, state of solute is the liquid, state of solvent is the gas. Example, chloroform in the nitrogen. State of solute is the gas, state of solvent is the liquid. Example is carbonated water or oxygen in water. Next one is the state of solute gas, state of solvent solid. Example, hydrogen in palladium. And last one, gas. The good example is air. Now we check the next one, capacity of solution to dissolve solute. The maximum amount of solute that dissolve completely in given amount of the solvent at constant temperature, which is known as the solubility. So dear students, we take good example as usual sugar solution. It dissolve readily At first, the dissolution rate of the dissolution is slows down as more solute is added. If we continue the addition of solute, the dissolution is stopped. The solution at this site to be saturated. The dynamic equilibrium will reach at the number of solute molecules having the crystals, that is, they are completely soluble, and hence we say that the solute plus solvent, that is, here solute is which one? Very good. Solute is the sugar and solvent is the water. So sugar plus water, it gives the sugar solution. Forward reaction, it is showing the dissolution, while the reverse reaction showing the crystallization, and hence we get the more amount of the solution in the formation of dissolution. Once we go in the reverse reaction, we get the crystallization. Sugar is added to water with continuous stirring. Molecule of sugar separate out from the sugar grains. Initially the solution is dilute and slowly concentrated of sugar in water, which is increases. During this motion, the molecules collide with each other and also with the solvent molecule. They are held together by physical force of attraction. If the force of attractions are insufficient, then the dissolved sugar is crystallized out. And if addition of sugar is continuous, then stage is reached when added sugar is dissolved in the solution. Hence, simultaneously crystallization is also out at the same time. So, initial rate of the dissolution is very high, while rate of crystallization is very low. With increase in the concentration of sugar in the solution, the rate of dissolution is decreases, but the rate of crystallization is increases, and hence finally a stage is reached. At this stage, the dissolution is exactly equal to the crystallization, which is showing in the equilibrium form. Now, the solubility, the solubility of the solute is its amount per unit volume of saturated solution at a specific temperature. So, all of you well know that the solubility, which is always expressed in the concentration unit mole per liter. The solubility is very important because the different factors are affecting on the solubility. So, first we start with the nature of solute and solvent. The substance having the different some substance having the similar intermolecular force, they are likely to be the soluble in each other. Generally, we take the example of polar solvent, for example water and once again sugar, or water and salt, where they are showing both are polar in the nature and hence they are dissolved completely. Water is in the polar form. Polar means what? Which having the positive and negative charge. So, it can dissolve polar and ionic compound. While in the non-polar component, for example oil in water, both are not dissolved completely, and hence their example is like the cholesterol, which is dissolved in the non-polar solvent. Oil is non-polar and the molecule which is extremely large. That is the reason the oil cannot be dissolved in the water. The dissolution of sugar is simple possible. Why? Because it contains the intermolecular force of attraction. Intermolecular hydrogen bonding is present in between of water and sugar, and hence like dissolve like, it guides to predict the solubility of solute in a given solvent. Next, second factor which affects on the solubility, effect of temperature on solubility. So, all of you well known that the solubility of gaseous liquids and solid solutes, they are affected by change of temperature. So, the solubility, generally we say that the solute in liquid which can be increases with increase in the temperature. So, solubility of solid solute is almost double with rise of temperature by 10 degrees centigrade. This is not always true, but solubility of